Well, shall we get started? And Ollie, I can't hear you. Ollie, can you talk? I can see you. Barbara, can you still hear me?
Can. And I see Ule Tron's screen seems to be coming up.
Okay. You can't hear me, though.
Oh,
we can
hear
now.
you now.
You can now. Okay, excellent. So, Bob, take it away.
I'm not sure I'm awake enough, but welcome to Six-Man Working Group IETF108. We have an hour and a half or so, I think. Why don't we, next slide. We're using, obviously, we're all on Meet Echo now. We will present the slides. So you don't need to share anything. If you wish to speak, enter the audio queue. There is also a way of just speaking directly. I think that's probably not the best way to do it. We will manage the queue if you request it. And when you speak, please state your name. The blue sheets are automatic. There's nothing to sign. And the notes are on, I don't know how you say that, code med something. And there is a participant guide for the session and Meet Echo documentation. Next slide. And here is note well, so please note it well. Next slide. The usual information, Jabber Room. Well, you should have found the link already. Barbara Stark is taking minutes. We thank her again.
George is helping out.
Oh, good. And we, I think we still need a Jabber scribe. Or do we need a Jabber scribe?
It's. I mean, both of us see the queue, and I think everyone is on Michiko, so I'm not sure if we really need one. But if someone want to step up, that would be great.
Okay. Yeah, I mean, I have a Jabber window opened up on my other display. Okay, this is the agenda for today. And any agenda bashing? Okay, I'm not seeing any requests. Next slide. And this is, we have a 15-minute session on Friday. And so we, yeah, go back one slide. So we organized this with the working group drafts today, one active internet drafts, and then a new individual draft today. Hopefully we'll have time. And then the next slide. And then one working group draft on Friday, the PathMTU, a report on the PathMTU option, and then 4 new internet drafts. Okay, next slide. Okay, Oli, do you want to do document status?
Yes. So since the last IETF or the last interim meeting, we have published one RFC. It's the RA preference 64 option. We have one document in the editor queue, which is the ICMP limits one, and we have finally submitted the temporary address extensions to the IESG, and currently nothing in last call. In working group last call, we have two documents. It's the OAM for segment routing and the gratuitous neighbor discovery one. The gratuitous one we'll talk about on the agenda. The OAM one, I believe, is now past all the outstanding comments and is ready to advance. We have two working group documents. We have the path MTU hop by hop option, that's on Friday, and then the alternate marking method, which we'll talk about later. So we had two somewhat outdrawn and contentious last calls. It's the one on the CRH option, the compact routing header. So we sent out the statement here, which basically says that we reached an impasse and we're now awaiting the outcome of the spring design team. That was discussed if you were in the spring working group yesterday. It was discussed briefly. So there are still some concerns from our side, I think, on the expedience and timeline for that design team. I think they initially planned to report, somewhere around IETF 109 or 110. So we had to follow that closely. And then there is the improving. Well, hang on. So Andrew, yes, you can have a comment on that. Let me just click on the button. Andrew.
Yeah, so it's Andrew here from Liquid. I do have a question about that timeline because I've obviously been following that. Now, the current status of that, as you mentioned in spring, is actually at best IETF 110. Now, that leaves me rather concerned because, that's quite a way away and this document has been around for a while. So my question to this working group is, are we going to sit and have to wait for something that's going to come only in IETF 110, considering that CRH is likely to go full production deployment in code in routers within the next month or two? I mean, it's deployed and it's functional, and to have to sit around and wait, all that's going to result in is more development that is happening on something outside of the auspices of the IETF, and that can lead to all sorts of problems later on. So what are we going to do if we cannot bring that time frame forward?
So I think my answer to that is we're not quite sure. I think speaking for myself, I think I was expecting something sooner. I think they did report yesterday that there would be some sort of first report in about a month or something. And so I'm looking to see what that says. But I agree. I thought that the timeline that was presented yesterday in the spring was excessively long to get this issue resolved. So we will follow this. We're discussing this with our area directors, and we understand your concern. And so Ron is in the queue for.
I think Ron, you're trying to share a screen. I think.
I don't think I'm sharing a screen, am I?
No, you're not yet. I think you possibly tried to. Yeah.
No, I just. Do we have a red line date? A date at which we'll say we can't wait any longer? I'm not interested in knowing exactly what the date is, but do you have one in your head?
So The simple answer at the moment, we do not. I mean, this was news to us yesterday. We were expecting something sooner, so we'll have to follow it and let the working group know.
Can I put you on the hook to like publish a date by a date?
I think
no.
it's very unlikely that we will get a date, but I think we should keep following up on this, and I'm sure, Ron, you will keep us honest on that as well.
The reason I keep pinging you about that is no date and no answer is the same as,
Understood.
Okay.
So thank you.
Okay, and then so that was the CRH document. So I think that will be an ongoing action item for us all for quite a while. Then we have adopted the robustness for Slack document. We kind of adopted the problem but not the solution. So that's but that's also on the agenda. So we'll talk more about that later. Any other comments on the document status before we move to the first presenter? Fernando has one. Fernando, go. We can't hear you if you're talking. We still can't hear you.
Do you want to advance, put his slide up?
It might be. I don't know if you had a comment, but yes, it's not Fernando's.
Bob,
I'm on the call.
sorry.
But it's interesting. I think Ron grabbed my screen sharing. Let me see if I can start that again. We are going to have some hiccups with this tool, so just bear with us. Okay, Fernando, we can take your comment later if you get your audio fixed. In the meantime, let's start with the alternate marking method. Giuseppe, are you here? Okay, you should have both video and audio, I think.
We can see you.
But you can hear me. You cannot hear me.
And we can hear you.
We can hear you. Go ahead.
Okay, good. Yeah, this is the update about the application of the alternate marking method to IPv6. So next slide, please. Yeah, just to give a recap about the methodology, the reference document are bot RFC, we can say, because we have RFC 8321 and the multi-point mark draft that is in the RFC editor queue. In a few words, the methods consist of batching packets based on time interval and by using 1 or 2 bits for packet loss and delay measurement. Next. Yeah, regarding the IPv6 application, just recap about the discussion we had in 6 months during the last month. The preferred choice in the end was the use of option header, both op by op and or destination. The source node is the only responsible that writes the option header to mark alternatively the flow, while in case of op by op, the intermediate nodes may be configured to read this option or not, and the measurement can be done only for the nodes that are configured to read that option. For destination option header, the option is not processed by any node along the path until the packet reaches the destination nodes. Next. So, just a summary of the change that we made during and after the working group adoption code. So the draft was adopted some months ago, and yeah, we got some comment from Tom and Eric that helped a lot to improve the document. In particular, the comments from Tom were very useful to build a new section on the uniqueness of flow monitor ID, and the comment from Eric helped to improve the security section. After the feedback from Ron that we got during the last week, we also plan to work on a new revision in which we will include a new section on timing aspect, and we want to describe how the alternate marking is resilient to reordering. That is already described in RFC 8321, but it's important also to point out here. Next. Yeah, the draft introduced the alternate mark option. We have the usual TLV format in which the first 3 bits are all 0 because you have to skip if you don't recognize and data do not change en route. While in the red box, we have the important fields for the alternate marking operation, in particular the loss and delay flag, and the flow monitoring identification field. Next. Yeah, the flow monitoring identification field is required for some important reason. The first one, it helps to reduce the per node configuration, because you can imagine that if you have a lot of flows, you are going to configure a lot of access control lists to select the monitored flow. So the flow monitor identification will also allow a flexible granularity for flow definition. It also simplifies the counters handling. And also in case of tunneling, it eases the deep packet inspection. So having the flow monitor ID also helps in this direction. And it is also helpful for the collectors and controller for the data export and correlation. So next. Yeah, this is the first section that we introduced after the comment from Tom. To allow the disambiguation of flow monitor ID in case of collision, there are 2 possibilities. The first one is to use a centralized controller. It is responsible to set the flow monitor ID and instruct nodes properly to avoid this collision, because of course the controller has the view of the network and how the flow monitoring identification are distributed. In case the flow monitor identification is pseudo-randomly generated by the source node, the situation changes because there is a probability of collision. For example, if you have 20 bits, there is the 50% chance of collision for just 1,206 flows if we use the so-called birthday probability problem. So for more entropy, we can either combine the flow monitor ID with other fields like IP addresses or flow label. Just in case in a controlled domain, we can ensure that the IP address and flow label can be considered stable. Or the flow monitor ID size could be increased by using, for example, the reserved bits in our data fields. Next. Yeah, this is just to recap the alternate mark option alternatives, the destination option, op by op, or the destination option plus any routing header. In this case, it depends if we want to monitor only end-to-end, only op by op, or if we want to monitor every destination node in the route list. It is worth mentioning that in case of op by op, we are all aware that the op by op option is not well supported. But anyway, it's important to say that for this methodology, there is no strong requirement, and intermediate nodes should ignore this hop by hop option, but this does not have strong consequence on the application of the methodology, because the performance measurement does not account for all links and all nodes, but this is not so important. So just we can skip the nodes that are not configured to read the hop by hop option. So next. Yeah, this is the improvement of the section about the security. We classify the security concerns about the harm caused by the measurement. In this case, of course, alternate marking implies some modification on the option header, but this must be performed in a way that doesn't alter the quality of service. Of course, this is easy to achieve since we are just changing 2 bits and only for the source node. So there is no change in route along the path. Regarding the harm to the measurement, this is more important since the alternate marking measurement could be harmed by routers or attacker that can altering the marking of the packet or injecting artificial traffic and so on. Anyway, we can say that in the context of a control domain, the network nodes are locally administered, and this type of attack can in some way avoid it. On the other hand, an attacker cannot gain information with just one single monitoring point, but he needs to use multiple monitoring points to apply the methodology and to gain real information about the performance. So the methodology implies that there is no information on local nodes, but on multiple nodes in a synchronous way. And regarding the privacy concerns, we can see that are limited because the method only relies on information in the option header without any use of user data. Next. Yeah, this is the last slide about next steps. So in particular, yeah, we found an agreed way in 6 months to apply these methodologies. The next step may be the IANA IPv6 parameters. In particular, we are looking for the temporary assignment to test the implementation. And of course, the question and comments are always welcome. Thanks.
Thank you very much. So any comments? Igor, you're first. Go ahead.
Hey, it's Igor Lubashev, Akamai. So first of all, I think it's definitely very important to have loss information. And we've discussed it in, I presented actually multiple times in TSVWG how important it is. So it's great that there is some more thinking in 6man. I am somewhat concerned that, well, I'm actually more than somewhat concerned that the thinking right now is purely about controlled domains. So that's a very limited area. And the more it's very important to have loss information, especially in the presence of encrypted protocols, to be available on a wider scale. So like basically truly end-to-end on the internet. And one of the things that would immediately prevent it is so non-optional flow man ID could be considered by many people as a privacy concern. And it looks like in at least context of transport protocols that provide flow identification themselves, some people could consider it not necessary to be mandatory. So that's one comment. The other comment I have is that we call it loss bit. It should better be called upstream loss bit. And in our draft that we presented in TSVWG, we actually provided also additional bit for the downstream loss information. It would be a good complement to release that, to specify that additional downstream bit. So we have a TSVWG draft that basically shows how to do it for any generic transport protocol that actually keeps track of losses. So that's basically my comment about this. Thank you.
Okay. Yeah, thank you for your comment, firstly. Regarding your last words, I think that in this case, we don't have round trip measurement. So this is one direction measurement. So it does not make sense to define upstream loss bits or downstream loss bit because this is just one direction. So it's a point-to-point measurement in this case, or point-to-multipoint, but only in one direction. So if you want to make two direction, you have to couple by yourself, so the controller can do that. But for IPv6, it's just one direction, like the base RFC 8321 and multi-point alt-mark draft. So it's not bi-direction.
So Giuseppe, I would
Regarding
yeah, sorry. Let's stay with this point for a second. I would recommend you to review our draft because the upstream loss bit, loss bit is also reported in the same direction as downstream loss bit. So it only requires a single point to it's only one single point to multi-point. So it's not, you don't need return any return traffic. It's the same sender that's sending alternate markings is also sending additional bit that is basically controlled by its recovery machinery. So I invite you to read the draft again.
Okay, so can we
Okay, I will have a look.
can we bring the rest of this discussion to the mailing list? We are over time, and we do need to manage the time carefully because the Meet Echo session will end quickly.
Okay.
We have a 5-minute window to go over, but after that it will shut down. So thank you. Why don't we go to the next presentation?
Fernando, you are up. Let's see if we can get your audio working. Okay, Fernando, you should have audio granted. We cannot hear you.
Okay.
Now we can hear you, I think.
Okay, perfect.
Yes, go ahead.
Okay, I'm not seeing my slides on the screen. Is that okay?
Oh, hang on. Seems like, yeah, let me stop and start that again and see if that helps.
Okay.
Oh, it shares one tab at a time. Yeah, that's slightly broken. Okay, now you can see them.
That's perfect. Awesome. Okay. So I'm Fernando Gont, and I will be presenting the document on improving the reaction of IPv6 SLAC to flash renumbering events. Before I start the presentation, may I ask the question that I was going to ask before when my audio wasn't working?
Yes, I guess you can try quickly.
Okay. So my question comment was that while you were describing the result of the consensus process, you mentioned that there was consensus or agreement to work on a problem but not on the solutions. And I went through the comments through the mailing list, and there were, say, 2-3 comments with concerns about one specific section on of the document, but what I've seen so far is that there wasn't let's say objections against the rest of the document. Like, in any case, so that was my comment, so to speak. And in fact, when it comes to some of the objections that were made, the ones that I remember were kind of like vague, like, okay, well, this will make SLAC fragile, but when I asked it for clarifications on what specifically they meant, because it's hard to agree or disagree with a statement that is vague, like well, this makes it fragile, without providing like a scenario where things might break. So that was my problem. But in any case, during my presentation now, I guess we can focus on each on the topics, and if people have concerns, they may raise them.
Good. I mean, what we would like to see is discussed here, and then on the mailing list is proposal for specific text in each subsection, and then
Perfect.
We want to see the working group response to that.
Okay, fair enough.
Most of them shouldn't be an issue.
Fair enough. Can we move to the next slide? Awesome. Okay, so essentially this document, tries to mitigate tries to improve the reaction of SLAC to flash renumbering events, and we try to, improve things in different areas. One of them is to employ more appropriate prefix lifetime values. The other area is that we try, we propose some tweaks to Slack so that information is delivered or transmitted in a more in a time-layer manner. And finally, what we try to do, which is, I guess, where most of the concerns or objections have been, is a mechanism that tries to find out when information has become stale. So what I like to do is I will go through each of these three areas, and after each of these three areas, we might get comments from you, so that we don't have to discuss the whole thing all together. Next slide. So the first one is about the prefix information lifetimes. So if you look at the spec, there's a default value of 1 day for the valid lifetime, and there's a default value of a default value of 1 day for the preferred lifetime, and a default value of 1 month for the valid lifetime. So that essentially means that these timers will never go off in any meaningful time frame. So our proposal is essentially to change these timers as a function of the router lifetime. So specifically, what we say is that the preferred lifetime should be set to the same value as the router lifetime. Obviously, we are talking for the case where it's a non-zero value, and that the valid lifetime should be a multiple of that. Could be, for example, 3 times that, which is the normal thing for many RFCs. This obviously doesn't completely solve the problem that we have at hand, of course, but it does help in the sense that stale information will be deprecated even if a router goes away, or will be eliminated in a more time-layer manner. Next slide. So what I just described, of course, is a change on the router side. Okay. Now, obviously, let's say the limitations or the problem with that is that in order for that to take effect, like widely speaking, then you need every router to be updated accordingly. Okay. And in the near or long term, that might be acceptable, but not in the shorter term. So the other thing that we are in the document is that hosts, that is on the receive side of Slack, they can cap the lifetimes of the prefix information options with the same logic that we described in the previous slide. So that means if the prefix, for example, if the preferred lifetime value that a host receives, it's much larger than the router lifetime, then the host would nevertheless use the router lifetime value as the preferred lifetime. Okay. Similarly, for the valid lifetime, that would be a multiple of the router lifetime. Of course, there is this should only, or there is specific cases where this shouldn't be applied, which is when the router lifetime is set to 0, because that's a special value that essentially means don't use this router as a default router. So it wouldn't make sense to use that value, to set the prefix lifetimes. And the other 2 cases is when the lifetime value is set to all Fs, because that's infinity. So potentially there could be a system that is setting a prefix to infinity. That means you should use it forever, even if you don't hear from me again. So that's so far when it comes to using the more appropriate lifetime values for the prefixes. Router side in the previous slide and host side in this slide. So I'm wondering if the group has any comments on this.
Dave, go ahead.
Dave Taylor. So since I haven't looked at this recently, your slide looks okay to me as long as one thing is true. Can you confirm when you have like multiple routers, is it the case that the host only ever extends the lifetime of that state and never reduces it? So I'm thinking of the case where two routers are advertising different, say, router lifetimes, and what happens to the prefix lifetime? Is it the max of the two? If you just confirm that. And also there's a case where one router is actually counting down to 0 because it knows it's going to be reset, say, an hour from now, and so it's constantly counting down in some implementation, but it's not quite 0 yet. And so if you can just confirm that it's always the maximum, then I think your slide is fine. So.
I think we under-specified it in that respect, but certainly we should be explicit about that and use the maximum, as you say. Yeah.
So Yoshifumi, are you intending to enter the microphone queue because you asked to share screen and video? If so, enter the audio queue instead. Otherwise, we'll decline you. Go ahead, Fernando.
Okay, so let's move to the next one. Okay. So the next group of mitigations that we were referring to was that of having information be conveyed or transmitted in a Tumblr manner. Next slide. There you go. So if you look at RFC 4861 in section 5.5.3, item E, essentially the RFC says that if you get a prefix information option with a valid lifetime value smaller than 2 hours, you should essentially disregard it. Or to put it in a different way, you should never reduce the lifetime value of a prefix in response to a PIO option to a value smaller than 2 hours, okay? Now, the reasoning that the RFC gives is that that would be an attack, that could be considered an attack vector, okay? So by refusing to react to such a PIO, then you are in a way mitigating, that attack vector. But, from our perspective, essentially you have so many different attack vectors in Slack that either you trust RAs or you don't, or to put it in a different way, you implement first hop security or you don't. From the perspective of an attacker, even with this mitigation in place, you could do neighbor cache poisoning, you could disable routers by spoofing packets with a router lifetime of 0, you could flood the host with RIOs and PIOs, like as many as you want. You could cause nodes to use a hop limit of 0 or 1 or something so that all of their packets get discarded. So the point is that, from our perspective, it doesn't make much sense, to try to mitigate one particular vector when you have so many others. Now, on the other hand, this specific item in 4861 essentially prevents cases where you have a router that knows better that a prefix has become invalid, and this item in the RFC essentially prevents the router from signaling that condition to the host, and in particular for the host to react to that condition. Okay, there are multiple cases of that. You could have a CPE that is using a backup connection, now switches to the main one. Now the prefix has changed. The router knows that the prefix has changed. It could signal the condition, but this item in the RFC will prevent hosts from reacting to that. So our proposal is essentially remove that specific section, or modify it in a way that hosts will react to all valid lifetimes, including valid lifetimes that are smaller to 2 hours. Next slide. This is also in the same area as trying for information to to be spread in a Tumblr manner. Essentially, if you look at section 6.2.4 from our RFC 4861, the RFC says that in cases when an interface becomes an advertising interface, meaning that you will start doing Slack with that interface of the router, the router may transmit up to blah, 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 unsolicited advertisements, okay? Now, our proposal is to change that may to a should, okay? And the idea is quite simple, that, you know, whenever the information has changed in the router, you really want that information to be spread in a time-layer manner, okay? Besides the discussion that we had on the mail list, we also had some off-list discussion with a number of folks. And Chen suggested that, so right now, the document specifically proposes the change that we have in this slide, okay? Change the may to a should when for an interface that becomes an advertising interface. Now, Jen has suggested that we probably should recommend these too for the cases where the information that is to be advertised changes, not only when an interface changes from non-advertising to advertising interface, but also when the information has changed. So any comments on these past two, that of reacting to PIOs with a small valid lifetimes, or this one about interface initialization?
No one jumping up in front of the microphone as far as we can see.
Okay, so I will go on, and in any case, in the by the end of the presentation, we can discuss any remaining items. Now, the last group of the mitigations that we have in the ID is section 4.5, or what was section 4.5 in the individual version of this ID. And it is essentially an algorithm and a mechanism to try to detect when information has become stale, and in those cases, try to deprecate it and subsequently invalidate that information, okay? So, as an overview of the document of the mitigation, in the next slide I will go a little bit more into detail. But essentially, the algorithm is composed of two different parts. Okay, the first part is the trigger. Okay, in which situations, in which scenarios, what are the things that causes a host to try to verify or check whether information has become stale. So what we do for the case of prefix information options, essentially is, the host keeps track of the prefix information options that it has received, okay? They already do that. Now, if you receive an array that is advertising PIOs, but one of the previous PIOs that you had received before now is missing, then, should trigger, or what we say is that should trigger the host to try to validate whether that information, is still fresh. Then the second part is the deprecation and invalidation part. Okay, so what do you do when you think that the information has become stale? What we currently do in the document is to try to react in a passive way in the following way. When you receive an array that contains prefix information options, but one PIO is missing, then what you do is you update the lifetimes for that previous PIO, and obviously for the corresponding addresses, and you set the preferred lifetime in the order of a number of a few seconds, and the valid lifetime to a much larger, small value, but still larger. Could be, for example, a multiple of that, or you could set it to the router lifetime, for example. Now, the idea is quite simple. If the information is fresh, then obviously these timers will be refreshed and nothing happened. On the other hand, if the information had indeed become stale, okay, these timers will go off, and that means that first, the prefixes will be deprecated or unpreferred, if you wish, and subsequently and eventually, yeah.
There's a long discussion on Jabber now about which slide you're on. Do you want me to advance to slide 7?
Sorry, yeah, sorry, that was my bad. Next, that one, yeah, exactly, my bad. Apologies for that. So we have like a trigger condition. You receive an array that contains PIOs, but is missing a previous PIO. And that triggers the, let's say, deprecation or possible invalidation, in which what you do is you reduce the valid lifetime and the preferred lifetime. You set the preferred lifetime in the order of a few seconds, and the valid lifetime, for example, to the same value as the router lifetime. What we do, the idea of setting the preferred lifetime in the order of a few seconds, as opposed to setting it to 0 right away, is for the case, the theoretical case, where the information, where the router might be splitting all the information into multiple arrays. Okay, so rather than setting the preferred lifetime to 0, right away, we set it to a value for around 5 seconds, meaning that if the information is split, then right after this array, you will get the other missing information. Okay, so obviously, the good part of this, and the idea of this, is that as long as you implement this in a host, no matter what the router is doing, you are able to more gracefully handle the case where there is flash renumbering. Okay? Next slide. Okay. So
hang on. So we have a question from Dave. Let's see if we can take that on slide 7.
Yeah, please.
Dave, go ahead.
I just want to confirm that on slide 7, if you can go back one, where it says if you're missing the trigger, an array that receives PIOs but misses a previous IO, I want to confirm you would mean that to say but misses a previous IO from that particular router, right?
Yeah, exactly. Yeah.
Okay, great, thanks.
Yeah. And so yeah, this one. So this is essentially the same thing, but with a little bit more of detail. What we do in the document, and from our perspective, this is, let's say, an improvement over the algorithm, is to split things for global addresses and ULAs. Personally, I don't think that this is really necessary, but I think that this is an improvement over the algorithm. And essentially, the idea is as follows. You handle the case of global addresses separately from ULAs. The reason for that is that the idea is that you will only deprecate global addresses if you have a new global address. And you will only deprecate the stale ULAs if you have some sort of ULAs, of new ULA. So the idea with this specific algorithm that we have in this slide is that the algorithm will deprecate global addresses only if there are fresher global addresses, and will only deprecate ULAs if there are fresher ULAs. Otherwise, if you don't do this optimization, if you wish, then you might get rid of all the ULAs and only keep, let's say, fresh global addresses. Now, same as before, you receive an array that contains PIOs for global addresses, but a previous one is missing. So what you do is you set the preferred lifetime, for example, to 5 seconds, the valid lifetime to a value larger than that. And again, as before, if the prefix is valid, those timers will be refreshed, nothing happens. But on the other hand, if the prefixes have become stale, then you will quickly, unprefer those prefixes and addresses, and also will eventually get rid of them, will invalidate them. Same thing for ULAs. And as Dave asked it before, we are very explicit about this in the document, that in the case where multiple routers have announced the prefix, instead of getting rid of the address, what you do is you disassociate the prefix with that particular router. So essentially, that's like changing the local state and saying, okay, well, this prefix has become stale for that particular router. Or to put it in a different way, we say, okay, well, that router is not announcing that prefix anymore. And now the fate of the prefix and the corresponding addresses will depend on what the rest of the routers that were advertising that prefix are doing. Of course, if the prefix has become stale for all of the routers, then of course you disassociate the prefix with all of them, and the addresses and prefixes will get unpreferred and invalidated, eliminated. Any comments?
So Jen has a comment. Let's see. Jen, go ahead. Jen, we cannot hear you.
Can you
Go
hear
ahead,
me?
Jen. We can hear you now.
Okay.
Yeah.
Oh, beautiful. Sorry. So I'm slightly confused here. So is it more or less the same algorithm you had in the text before the adoption?
Yeah.
Like
What
you
we are
basically
doing is discussing.
Yeah, so like I think we've discussed it before, right? This algorithm looks a bit fragile in case of arrays being lost or information being sent in multiple arrays, right? And also, I do not think there are many implementations which are properly associating prefix with a router. I'm still not sure what would it mean for existing implementation.
So the thing with that is, I'm not sure why you say that it is fragile. In the case, could you elaborate on that? Why you think it is fragile when packets are lost?
So I'll take it on the list here because I don't think I think it would be easier to discuss on the list here while it's fragile.
Okay.
But I think I'm just confused because I think it was a lot of disagreement about this particular section before the adoption, and adoption seemed to be done assuming this section will be rewritten. So I'm not sure why you're proposing the same text again. So do you think we'll change our mind?
So what the chair suggested, if I understood correctly, as part of the adoption process, is that the group would discuss each of the mitigations that we had in the document. So essentially what we did, if you look at the draft IETF version of the document, none of these texts, no one of the slides that I discussed before are in the document. But essentially what we are doing is discussing each of the mitigations for people to either agree or to disagree. And in particular, when it comes to the section that we are discussing right now, I mean, for example, you have made like the comment that this algorithm is fragile, but I asked it if you could elaborate on that. As I mentioned on the mailing list, a comment such as, okay, this is fragile might be correct, you might be right, but if you don't elaborate on a scenario where things might break, it's difficult to agree or even to disagree with that.
Okay, and then we have Ted in the queue if you don't want to interject, Jen. Ted, go ahead. We can not quite hear you there, Ted, if you are trying to speak. Now you have the floor.
Actually, the issue is a
There we
browser
are.
issue. Sorry about that. Yeah, so the question I had is, do we actually have any data about this? Because I think that the question that Fernando and Jen are debating is actually not a theoretical question, and that we could collect data and actually see, whether this is a real problem or not. And I'm just wondering if this, for example, this presentation and this draft is actually motivated by data that's been collected that could actually be looked at, because that would really be helpful in resolving these questions.
So what you're asking is whether the problem that we are trying to solve doesn't actually occur in practice? No, that's not what I'm asking at all. What I'm asking is if you've actually formally collected data in a way that can be analyzed. The reason I ask that is because my experience in practice has been similar to yours. So I think that this is an issue, but the problem is that it's hard to resolve these questions without any data to refer to. And I think that's the case right now, unless you have some data. And when you ask about the data, what specifically are you referring to? What kind of data? What specifically would you like to be measured, so to speak?
Well, so you could put you could do some data collection on devices that are connected to IPv6 networks that just notices like whether router advertisements are being missed or not, whether prefixes are you know, being lost, and then, for example, implement this algorithm, run it on a collection of devices and see what happens. Do we in fact find ourselves losing PIOs that we actually shouldn't have lost, and so forth. And right now we just have, as far as I know, no information about this.
An additional question: when you say losing PIOs, you mean like if the flash renumbering events occur, whether the array packets get lost or something else?
No, we know that if a flash renumbering event occurs, that we're going to have issues. Like, I don't think anybody's questioning that. The question I'm asking is, if you did this thing to mitigate that problem, what would happen? Like, would we in fact, and you can test this already on you don't even have to change the implementation. You could just set up some code running on a bunch of devices on your network that just track, like, how often do I miss a PIO? If I were running this algorithm, would I lose my prefix? And that would be really interesting. And I don't think we have that data right now. This is something that I'm very concerned about. So I'm not saying you're wrong. I'm just saying it would be nice to have the data.
Okay. Point taken. I think there's are there any further comments before I continue?
Yes, we have Dave in the queue as well.
Okay,
go
cool.
Dave.
Just looking back at 4861, because there's another case that I'm potentially worried about here. 4861 says that you can have, and here the question is, if I have a bunch of off-link prefixes, right? And so it talks about how there can be multiple instances. If the number of included options causes the advertisement side to exceed the link MTU, the router can send multiple separate advertisements, each containing a subset of the options, right? So consider the case where for some odd reason you have a very large number of off-link prefixes, and you split them across two arrays because of this rule in 4861. What do you want to happen?
What would happen is that the first one that when you receive one of them, it would reduce the lifetime, but then the subsequent array will refresh the timer, and then things should continue normally. So the algorithm does accommodate the case where you are, splitting the arrays.
Okay, I think that's right. I can't immediately see anything, so it sounds like you've thought through it, but that's the one case that I want to make sure your draft would cover in this case, that it's not on the slide. Okay.
It's not on the slide, but we did consider that case specifically. Okay. I could, if you wish, post the specific part of the mitigation where we discuss and mitigate that specific case.
You have about 4 minutes left.
Okay. So next slide. So here I'm trying to essentially mention or do an overview of all the things that were proposed as an alternative to this last algorithm that I just described. So Philip essentially proposed something different. Essentially, he suggested that the algorithm could sample a router and try to figure out, if the router is splitting information into multiple arrays or not. And then based on that, the host would know better how to react to the arrays that are being sent by the router. My personal take on this is that this is more complex in a way, and it doesn't really buy you much. But in any case, I'm mentioning this because that's one of the proposals that were made. And other proposals that were made were to, rather than try to passively deprecate information as we do in the algorithm that we proposed, to do something else and try to do some sort of active proving. There were different things proposed, like trying to do something with an off-link node. My personal take, or poll the router, using one of the prefixes that you're trying to deprecate. In particular, when it comes to trying to communicate with some sort of off-link system, I believe that wouldn't be appropriate here, because what we are trying to do is to check whether the information is still fresh. Now, whether you can use those addresses and whether connectivity is working with some sort of off-link system, that's like a different thing. Next slide, and last one. Now, what I try to do in this slide is, is to offer, let's say, an alternative for folks that that had some concerns about the algorithm that I just described. And when thinking about possible alternatives, from my perspective, essentially, whatever we do, whatever algorithm we implement for this, it will essentially consist of two parts, like something that triggers the detection of stale information, and what you do to actually check whether the information is fresh, or what you do to actually deprecate it. A possible alternative is to still use incoming arrays that miss a PIO to check some sort of detection of whether this information has become stale. But instead of reducing the timers, a host could send a unicast arrays to the router, possibly a number of times, retransmitting it as necessary. And if the missing information is not included in the responding arrays, then you'd consider that the information has become stale, and you would deprecate and subsequently invalidate it. What we have in this slide, that of sending unicast arrays, does not need to be mutually exclusive with what we with what I described in the previous slide. So you could still reduce the timers, but in any case, you could send a unicast arrays to poll the router directly and try to get the prefix information in a solicited manner, as opposed to via the unsolicited arrays. So that's another possibility that is on the table. If there are not any subsequent comments, what I like is that for folks that have any specific question or objections about any of these things that we have discussed, particularly if they have objections, if they can describe a scenario or what they have in mind where things might break, okay? That's either to find something that we missed, or if we think that the scenario that you are describing actually can be mitigated or wouldn't be a problem, to be able to tell.
Okay, Fernando, thank you very much. I think we'll have
Thank
to
you.
this up on the mailing list. What we'd like to see is you to sort of raise these issues probably in individual emails, and we can then go forward from that. Thank you.
Perfect. Perfect. Thank you.
Thank you.
Okay, so Jen, you are up. I think you have the audio already. Please go ahead.
Hello. So, next slide, please. So, quick recap. I hope you paid attention, but just in case, the problem we are trying to solve is actually described in another draft, which is V6Ops draft. And the problem is When a host starts sending traffic from a new IPv6 address, which has not been seen on the network before, host already gets all information about the default router, so it could send traffic. But when the return flow packets coming in, the router normally does not have any neighbor cache entry for that address, so it starts address resolution process, and meantime, most of those packets are dropped until the resolution is completed, which is undesirable because it basically slows down the process of connecting a host to the network. So, suggestion is when a host configures a new IPv6 address, let it advertise it by sending unsolicited NAs. The 4861 currently saying that if there is no entry, unsolicited NA should not create them. So we are proposing to change it and say that routers should actually create a stale entry upon receiving unsolicited NA. So next slide, please. The draft is currently in the working group last call. I submitted on Sunday the 0.1 version, which integrates most of the comments I received during the last call, and it also has a few other changes. So next slide, please. So first of all, I realized that the text was not actually clear because it was used host and node terms interchangeably, while it actually should not. So as per 4861, node is any IPv6 enabled device, and a host is node which is not a router. So Mark Smith pointed out that the proposed mechanism could be actually beneficial even for a router. So when a router creates a new IPv6 address, it could also announce it by sending unsolicited NA. So as a result, I cleaned up the text, and text is currently using the terminology of node. So it will, the proposed mechanism of sending NA will be applicable for both hosts and routers. Next slide, please. Also, 00 was suggesting using the mechanism for global addresses. However, there are some reasons for maybe using it for any address, including link local. First of all, it's easy to implement. Probably implementers do not need to do some ifs and else, right? Just whatever address you configure, send unsolicited NA. And also it might be beneficial in future. So currently I'm struggling to see the real scenario when it could be useful, but apparently I talked to some implementers and they believe it actually would be easier for them not to make this difference between link local and global. So the 0.1 version of the draft does not explicitly talking about global addresses, it's just saying IPv6 address. Next slide, please. Yeah, some tweaks or proposed updates to section 726 in 4861, basically which saying that a host should send unsolicited NA. I just found the better position in this section for the proposed paragraph. So please review this section of the draft. And the most important update, next slide, please. It's about avoiding disruption. I think I actually mentioned that on the last interim, but I'd like to bring it to your attention again because it's probably the most significant change in 0.1. So next slide, please. There is one very specific corner case when proposed mechanism might introduce some destruction in case of duplicate addresses happening on the network and optimistic DAT being used. So, scenario is this. Let's say we have a rightful owner, host A, which has configured an IPv6 address and starts sending packets. Before the return traffic arrives, but after that rightful owner starts using it, another host assigns the same optimistic address, sends unsolicited NA, and after that, the return traffic for the first host arrived. Next slide, please. What happens without the proposed mechanism, right? In this case, it will be a short period of time between receiving unsolicited NA and NA from the rightful owner when traffic might go to the wrong address. Next slide, please. It's very short period, right? What happened if router creates a stale entry? In this case, the stale entry will be used for sending that return traffic to second host, which is actually not the rightful owner. And in this case, the delay might be slightly longer. So next slide, please. So delay might be like, it would be 5 plus 2 seconds. It's about 7 seconds. In the worst case scenario, but next slide, please. The probability of this seems to be rather low, right? So for this to happen, two hosts needs to start using the same IPv6 address almost simultaneously, right? And the second host needs to send an NA before the return traffic arrives. So basically the question is, do we care about this corner case? Is it bad enough to not to proceed and do not get all those benefits of pre-populating the cache on the routers? I actually don't think so, but I'd like to hear the working group opinion. And I think my next slide is the final one. So questions, comments?
So Dave is in the queue. Dave, go ahead.
Yeah, I was just getting through the draft. I have a vague recollection. So thank you for the quick recap at the beginning. I have a vague recollection that I may have asked a question at a previous meeting that you answered. I can't remember the answer, and I was looking to see if the answer was in the document, and I couldn't find it there. And if it's not, my request would be, can you add the answer into the document? And so the question is, if I understand this right, and maybe I don't because we didn't go through the refresher at the beginning of this. And it was some time since I looked at this. So anyway, so the question is, does this require the host to change or only the router to change? If it requires both sides to change, then of course you may not get deployment anytime soon until both sides change. So I think the question that I asked at the mic at some previous meeting was something like, have you looked at having the router do something that does not require the host to change? And so if you can just clarify, does this work with existing hosts? And if not, maybe some rationale as to why you'd require a host change? Or is this something that works with existing hosts just fine?
So, thanks. So actually, I think what else can we do? It's in V6 soft draft. Because if you remember what happened, initially we had one draft, which was discussing all possible things we might do, starting
right,
from
I remember that one.
nothing.
Yeah.
And sending carets, doing other things, and then the document discussed pros and cons for all solutions. And so far, the conclusion was, let's do this. And all other options are discussed in V6 soft draft. You can look at this, and I think we're gonna, if you're going to publish this, they should be published together, right? Because they're referring to each other. So the thing is, first of all, as far as I know, there are implementations on the routers already which are doing this. So the thing is, RFC says should, right? I mean, currently 4861 says node should not create a new entry upon receiving unsolicited NA. It doesn't say must not. So basically, by doing this, you're not even violating anything, right? So we are not actually changing the router behavior, prescribed router behavior. We clarify in the RFC that routers probably should do this. Also, the only thing which you can do without making any changes on the host is to integrate data plane and control plane on the router, right? And then when the router sees some outgoing traffic flow, it could create it could start a neighbor discovery for that address. However, unfortunately, the problem with this is if you have two routers on the network, let's say VRRP, like first hop redundancy, there is no guarantee that your outgoing flow is crossing the same router as the return traffic. So and V6 soft draft actually discusses the requirements for the solution, and one of the requirements is I want all routers which can serve the return traffic to have the neighbor cache entry, right? And so far, the only way, besides actually looking at the DAT packets, but with DAT packets, there is other problem. You not necessarily see DAT packets, unfortunately, if you have smart wireless infrastructure. So the here there are different things you can do. Some routers actually do some of them already because they're not prohibited by RFC. This one is one where we actually need to update standards. So that's why here is the draft. Nothing prevents you from looking at V6's draft and do whatever else is described there as an additional optimization. And this doesn't break anything.
I think that you're saying the answer to my question about the motivation and rationale or whatever is in the ND cache-init draft, and you want them to be progressed at the same time, and that's why the rationale is not copied into this one, because the other one you intend to go to RFC, and the reference is where you'd find it. So I think that's the real answer to my questions. You want them to be progressed at the same time.
Okay.
Because what I was going to ask is, can the rationale be added into this document if the other one is just going to be, left or lag or whatever? But you're saying no, it's actually going to go in the other one, and you want it to be progressed at the same time. So thanks.
Okay, then we had Tom in the queue, but I think he withdrew. At least it disappeared in the tool. Tom, if you want to speak, yes. Okay, he withdrew. Thanks a lot, Jen. It sounds like we need another round on the mailing list before we go and advance this document. Excellent. Thanks a lot. For the next one, we have Fred Templin. Let me just share your slides quickly.
And Fred, well, so we are, for the session, we are over by about 13 minutes. So if you can do this in less time, it would be good. If not, we'll have to move Ted's talk to Friday.
Fred, you should have audio. What about now?
Hi, this is Fred. Is my audio on?
Your audio is perfect. Go ahead.
Okay, thank you. Yeah, Bob, I'll try to adhere to as quickly as I can on the presentation. So this is the overlay multi-link network interface. This is an IETF update and status. Next chart, please. So where this document came from is that it's been under development in the International Civil Aviation Organization Working Group by Mobility Subgroup for a number of years now. And at the mobility subgroup meeting in Vienna, Austria back in February, we decided to put a liaison statement forward to the IETF requesting publication of this document. And the venue that we're looking for publication would be as a working group document of the IETF 6-man working group. Next chart, please. So some status. We did put the document to the IETF. The IETF requested that we rename the document with 6-man in the name of the document. The liaison statement was submitted to the IETF back in March. We did present the draft at the IETF 6-man interim working group back in March also. And in terms of the IETF direction, the preferred approach is to publish as a 6-man RFC, and a backup approach would be to go for an AD sponsorship. And then the next step as of today is for looking for a 6-man working group adoption call. Next chart, please. So what about the Omni link that makes it something that should be of interest? It's a flexible virtual link model supporting RFC 2473 encapsulation and RFC 4193 addressing. It's a link model that is for an always mobile router with no home link and a portable Internet of Things with multi-addressing. And this is a 21st century archetype. It supports operation without access network configuration so that each node receives a stable and unchanging mobile network prefix. And we have stable and unique link local and unique local addresses that are statelessly derived from this mobile network prefix. And because of this mapping of the addresses, we have no care of addresses and no need for MLD version 2 or duplicate address detection. No home addresses or home link models needed. No prefix delegation messaging is needed, and it provides significant savings in avoiding costly unnecessary radio transmissions. Now it includes multi-link coordination parameters and IPv6 neighbor discovery messaging. What that means is that no adjunct messaging service such as binding updates would be needed. Next chart, please. It provides for safety-based and performance-based multi-link support. So each Omni interface connects to a distinct safety-based multi-link virtual link. Segment routing is used to select the safety-based multi-link interface and navigates the SPM topology. Each Omni interface is independently coordinated, coordinates its own performance-based multi-link. It's based on standard IPv6 neighbor discovery messaging with no adjunct protocol messages. So we have RSRA for router discovery and multi-link coordination, and NSNA for address resolution and neighbor unreachability detection. And it supports path MTU assurance and path MTU diversity. So it supports the native interface MTU without encapsulation reduction. So if the native interface is 1500, for example, you get the full 1500. You don't get some degenerate size like 1480 or 1460. And it does support MTU diversity up to 9180 bytes without MTU packet loss. And this observes the fact that fragmentation is always going to be required when encapsulating over links with 1280 MTU. There's no way around it. If you want to send an encapsulated packet over a 1280 MTU link, you require fragmentation. Next chart. Simplify security over access networks with Omni-aware access routers. So the RSRA messaging in the access networks between the mobile node and the access router are protected by physical and link layer security. And the access router can then coordinate with mobility service endpoints in the service network via secured spanning tree over the overlay network. So this is a network layer security for the spanning tree is used. And then VPN security and secure neighbor discovery can still be supported for open internet access networks. Like, for example, if you had a mobile node connecting through a Starbucks Wi-Fi or something like that. Omni supports what we're calling massively distributed mobility management because you can have many hundreds or thousands of mobility service endpoints, all servicing a subset of the nodes on the link. A single mobile node to ground RSRA message exchange can also be used for significant savings in over-the-air control messaging. Next chart, please. Okay, so because of the OmniLink 2473 encapsulation and 4193 unique local addressing, any mobility service endpoint can service any access links. So in the aviation domain, we have many network service providers. There are corporations known as CETA, Inmarsat, and AirInc that all provide internetworking services to airplanes. So we can have it such that a mobility service endpoint living in one operator's domain can service the links from an aircraft coming in through another operator's domain. And the Omni interface connects the mobile node to the OmniLink and allows multi-link coordination through a common mobility service endpoint, even though there might be multiple service providers. The Omni interface also provides for NAT traversal using the same encapsulation format and bubble messaging as for RFC 4380. And then we have the penultimate hop toward the final destination can use segment routing and encapsulation for route optimization. Next chart, please. So OmniLink local addresses are created by taking the mobile network prefix assigned to the mobile node. For example, if the mobile network prefix was 2001 DB812/64, then the OmniLink local address is formed by taking FE80 in the top 16 bits and then concatenating the 2001 DB812 as you see there in the boldface. That's how you form a link local address, an OmniLink local address. And then the OmniLink local addresses are easily translated into Omni unique local unique local addresses and vice versa. Next chart. So what the OmniLink is a virtual link model, again using RFC 2473 encapsulation, that forms a layer 2 spanning tree for spanning one or more internetworks. Now, I mentioned before about the Omni unique local addresses, and they're taken from RFC 4193 in a one-to-one correspondence with the Omni link local addresses. So, for example, if you had the Omni link local address, this FE80 2001 DB812, to get the Omni unique local address, all you need to do is clear bit number 6 to get FC80:2001 DB812. So in other words, Omni ULAs and LLAs can be converted one to another by simply flipping bit number 6. And what this is doing is it's defining a structure for the FC80 prefix for unique local addresses in the context of the Omni link. Encapsulated packets with Omni ULAs can then traverse IPv6 routers acting as bridges in the spanning tree to connect the segments of the Omni link. And the IPv6 neighbor discovery message can travel multiple spanning tree hops without decrementing the hop limit. And this provides us with a unique, unified, non-broadcast multiple access link view. Next chart. In terms of the aviation domain where this came from, again, there are many different aeronautical communication service providers, and each runs and operates their own internetworks. AirInkSeed and Inmarsat are 3 examples, and there will be others as well. And each internetwork is seen as a partition or a segment of the worldwide link over which the ATN IPS is configured. And OmniLink bridges disjoint internetworks into a single unified link with each internetwork and underlay as a separate segment of this bridged overlay. Next chart. So this actually had some animation sequences. What it's showing is the pink domains are the individual network service providers. The blue overlay is the Omni link. And what it's showing is that packets can be traversed without decrementing the hop limit over the Omni link overlay between the operator domains, making it look like one big network as opposed to many individual smaller networks. The packets that are shown in the lower left-hand corner, you have an original IPv6 packet. You insert the green RFC 2473 encapsulation header. That may require fragmentation then, in which case you have multiple fragments that traverse the link and then pop out at the other side as, again, a whole IPv6 packet. Next chart. Implementation status. There's at least 2 ways to implement this. One is from a user application using the TUNTAP interface, and a second would be through a kernel tunnel virtual interface in the same way that the Linux SIT and FAL drivers do it. We're currently instrumenting the arrow function as an add-on feature to OpenVPN, in other words, as a user application-based implementation, and we plan to release that in Q4 2020. We also have a custom ISOTAP-D that provides a bare minimum process context for arrow functions that we have as another option that we could go to. But our ultimate goal is to port this to the Linux kernel module, and we would expect then to use the Linux WireGuard facility for network layer security in any case. And next chart. Document status plans. The document name is Transmission of IPv6 Packets over Overlay Multilink Network Interfaces. It's an example of an IPv6 over foo document. It defines a new IPv6 neighbor discovery message option type called the Omni option. And the next step would be for a 6-man working group adoption call. And I think that's it. I think I've gotten through them all. Yes. I'd like to say that this deck of charts is actually quite large, and I'd welcome people to look at the deck for the backup materials because there's a lot more details about what goes on here. But I'll stop there in the interest of saving time.
Thank you, Fred. Oli and I and Eric have been discussing how to proceed with this. It is a lot of things, and we're not sure how much interest there is in the working group. So our current thought was to solicit on the mailing list to see if there would be people interested in participating in a design team to work with you on this, you know, as part of doing an adoption call. Because I think there's a number of separate areas here, and I think it's going to require a lot of detailed work, and we're not seeing enough traffic on the list as is. So that was the approach we were thinking about. So, so I think we will proceed that way. unless we hear otherwise.
Any other views on that? Eric, you have the mic. Eric, go ahead. We cannot hear you. We can see you talking.
Yeah, wrong button. So just to confirm what we discussed with Bob and Ule there. And by the way, it looks like the document has changed since the last time I read it in December or January. So we need to review it. My concern is that it's a document having a lot of things inside. That's a bag having multiple bags inside. And the document is quite complex. So Fred, is there any chance that you can separate a few things out of this document and making sub-documents, for instance, the MTU and encapsulation, to make things easier to swallow?
Well, my reaction to that, Eric, is that we already kind of do have it separated out as two separate documents. The interface spec is the Omni spec itself, and we also have the mobility spec, which is called Arrow, that we don't have as topic for discussion. So we already do have document separation. We have functions separated out. I really believe that all the pieces that are in the Omni spec need to be there. So that's my reaction, is that we already do have a document separation.
Okay, I need to review the document, to be honest, on this one. And we can proceed to the adoption call, if Bob and Ule agrees. And we see what's happened, right? We need to get people reviewing and being authors as well.
So I think we will work on that later in the week. Okay, good. Thank you, Fred.
Thank you.
Okay, excellent. So we have 8 + 5 minutes for Ted. Let's try to run that through, and then if we run over, we can do the rest on Friday. Is that okay, Bob?
Yes.
And Ted, you are let's see, I think you have audio. Please go ahead.
Can you hear me?
We can hear you.
Okay, so what I'm presenting here is some work that I've been doing on the problem of attaching stub networks to existing infrastructure networks. This is not necessarily 100% a six-man thing, but there's some really interesting six-man related stuff in here, so that's the reason I'm presenting it here. That means I'm going to be saying a bunch of stuff that's not actually six-man related when I describe it, but please bear with me. So go ahead to the next slide. Next slide. Okay, so the common flow we have here is the host connects to the network. Next slide. And then it discovers internet servers using DNS, and it can communicate with them. Next slide. So basically, that's like one of the things that a host can do when it's connected to an infrastructure network. Next slide. I'm just giving this as background for what I'm trying to do with the stub network. So again, we can discover services on the link using multicast DNS. Next slide. And then once we've discovered them, we can communicate with them. Next slide. We can discover, so if I have a device that I've connected to an infrastructure link, it can be discovered using multicast DNS if it's advertising any services. Next slide. And we can communicate with it directly because it's on the local link. Next slide. So the new flow that I want to talk about is, suppose we have something that we want to connect to an infrastructure network, but it's got a whole network behind it. Now what do we do? Can we do that? Do we have a way to do that? Next slide. So the picture here is we've got pretty much the same scenario. We have stuff we'd want to be able to communicate with, cloud services, devices that are connected to the infrastructure. But now we have a stub router that's connecting directly to the infrastructure. And behind that stub router, we have some number of stub devices that want to be able to communicate in the same way that I just showed you in the previous slides. So the stub device wants the same access to services that that a directly connected device would have. Next slide. So we know how to automatically connect individual devices to infrastructure, how to discover services, how to connect to services across the internet, how to, you know, and so forth. All of the stuff we know how to do from an individual node. Next slide. How do we do that from a node that's on a stub network? So the usual way that this problem gets solved is with NAT. Obviously, that's not what I'm focusing on here. What I'm focusing on here is suppose we actually just wanted to use IPv6. We want all the good stuff that IPv6 gives us, like end-to-end connectivity and things like that. How do we make that work? How do we automatically connect a stub network to the infrastructure? How do we connect services, so forth? Once we're connected, how do we do routing? Next slide. So there are a couple of cases where I think this is interesting. One of them is where you have a device like a mobile phone that has some other IP devices behind it that are using it as a router, and it would like to be able to access services that are on the local network. I mean, this device might actually be already connected to a cellular service or something like that, but maybe there's a printer in some device like your watch or something wants to talk to the printer. Being able to go through the phone to talk to the printer would be nice. Another example is a constrained network, so IoT, that sort of thing. You've got an 802.15.4 network. You can't connect 802.15.4 devices directly to the infrastructure because there are performance issues. So you can't just do layer 2 routing. Layer 2. You know, you can't merge the networks. So and the other issue with IoT is that you might have multiple stub routers connected to the same stub network. So these are kind of the problems that we face when we try to connect stub routers to networks. Next slide. And then the thing that is really key here is what I'm trying to come up with is something that would allow us to do this on existing networks. So we can't assume new functionality on the network, because if we assume new functionality on the network, that has to get deployed, and we all know how that looks, right? We all have watched the HomeNet experiment, and HomeNet did some really cool stuff, but you can't buy it. You can't buy a router that does HomeNet. If you could buy a router that did HomeNet, this whole problem wouldn't exist. But you can't. So how do you connect to, so suppose you have an existing IPv4 network. How do you connect a stub network to that and get usable functionality? Suppose you have an existing IPv6 network. How do you connect to that? And then, you know, you've got commercial networks where there might be DHCP service, and there might be, you know, complicated routing and infrastructure services. And then you've got home networks where everything has to happen automatically. So next slide. So when I was trying to make this work, what I was trying to do is figure out, like, what would I have to put on a device, on a stub network device, in order to be able to get IPv6 service, or to be able to communicate with devices on a stub network in the various scenarios that I described. And what I came up with is, if you've got an IPv4 network, we can advertise, right? We can advertise IPv6 service on the IPv4 network. It gives us reachability to devices on a stub network. It does not give us cloud reachability. On an IPv6 network, we can advertise another prefix that's reachable through the stub router. We may be able to get a prefix from DHCPv6. And so we actually have a lot of tools that would allow us to do IPv6 routing to a stub network, but we haven't really put them together. Next slide. So, so if we want to solve this problem, I mean, the obvious thing that we generally do is use RFC 1918 and IPv4, but that doesn't work for 6LoWPAN. And it makes it very difficult to connect from infrastructure to devices on the stub network. We can use IPv6 NAT, and that allows 6LoWPAN to work, but again, it's hard to connect into the infrastructure, from the infrastructure into the stub network. So if we have IPv6 on the link, then it's not so bad. We can create a ULA, and we can advertise the ULA on the stub network. We can advertise reachability on the infrastructure, and now devices that are on the infrastructure can talk to devices that are on the stub network. But devices that are on the stub network can't connect to the cloud because we're using ULA. If we have prefix delegation, then we can actually get a prefix that'll work on the stub network, and now we can connect to the cloud. But that requires some degree of managed network or some automatic stuff that's not currently specified in the router requirements document. So, and then, you know, if you want to solve a number of cases, you can get some of the functionality that you need by providing IPv6, so you can connect into the stub network, but you can also use IPv4 or RFC 1918 for connecting to the cloud with NAT64, so that 6 low-pan nodes can talk to the IPv4 network. So this is kind of a mishmash of stuff, but the key implication here that I wanted to get across, you can go to the next slide. The key implication here that I wanted to get across to the next slide, we don't need to talk about discoverability, so let's go to the next slide. So the thing that I wanted to present to Sixman is, in order to do this, we're taking advantage of some stuff that's not widely used right now. We're using router advertisements with router information options in them and router lifetimes of 0, because we don't have a default route. The stub network router is not providing a default route. So, and we're probably using short lifetimes because these are things that may come and go, right? Like if it's a personal area network and it's my iPhone, well, the iPhone, if it advertises a route, you don't want that route to stay around forever. I mean, nobody's going to try to connect to the route if they're not using it. So it's not creating a problem, but just in terms of neatness, you'd rather that didn't stay around for a month. So anyway, so that's the problem. I think that this is, I'm going to probably try and pursue this in int area, but I wanted to get this stuff on your radar, on this working group's radar, so that you'd know what I was working on here. And there's a document that that describes all of this in great detail. So let me see if there are any questions now, assuming we have time for any questions at all.
We have 3 minutes until a hard stop, and alternatively we'll continue throughout the week on the mailing list, and you know, if necessary, we could talk about it on Friday a little bit as well. But yeah, if any questions now, please jump up. I see no one. Yes, Alexander.
Real quick,
you have the floor.
Do you hear me?
Yeah.
Yes.
Okay, hello. So not much time left, but one quick question on this IPv4 target. Where does it come from? Why IPv4 target?
The reason that IPv4 even comes up here is because there are still, unfortunately, certain people in the world who do not have IPv6 native connectivity on their home network. And so we still need to make that work in principle. Now, in practice, you know, for the IoT case, you may not even need IPv4 connectivity at all, because you don't need to connect to the cloud. You can just operate stuff locally in the home or in the infrastructure, in the building infrastructure. So you don't need cloud connectivity in that case. But in the case of devices that do need to connect to cloud services, then I think it's necessary to assume that IPv4 is the way to get there in some cases.
All right, so we are about 45 seconds to go, so I think we're going to wrap this up. And thank you all very much, and we will see you on Friday. So have a good IETF week.
You too.
Gonna wait and see if it shuts down.